Assalamu alaikum student and hello everyone. Today we will review some example of all kinds of signal that we talk about in the previous lecture. Actually not all, but the majority. We will focus more about unit step and unit sample. And we can say 80% we will focus on unit step because unit step is a collection of samples or collection of pulses, not like unit sample has only one pulse when n equal 0. The value of signal or the amplitude is 1, only at 0. So we have only one sample. Yeah, that's why we use unit step more. So while unit step is regular discrete signal, got many samples from 0 till infinity, our amplitude is 1. Regularly discrete time means between each symbol 1 second or 1 minute or even 1 millisecond. So the important here that the time is fixed between each pulse. So the unit step got one amplitude from 0 till infinity. That's the general. And as I mentioned before, the general of unit step is not fixed, can be changed with three types of transformation. First, shifting the signal to right side or to left side. Second type, scaling, multiply the amplitude by some factor or some number. So the amplitude in generally is 1. So based on the given question, we multiply it by 5, by 10, or by -8, or any number that the amplitude may be increased or decreased based on the given scaling. And last type of transformation is flipping or reversal. So we flip the signal from positive part to negative part. Okay, or vice versa. We reverse the signal from negative part to positive part like a mirror. So let's start with the example. We have this example here. If you remember last lecture, in the previous lecture, we start to draw the original unit step first. Then we do the given operation. Now, no need, since we already understand the mechanism here, we can draw the solution directly. So here, 2u, okay, of n minus 3, okay? So -3 means shifting to positive side, okay? Once it's -3 means our start point will start at +3. So from +3 until infinity. Okay. Let's draw it. We start from +3, 4, 5 until infinity. And the amplitude here is actually should be 1, yeah? The original one should be 1, but here we multiply by 2. So our amplitude will become 2. And at 2, 1, 0, -1, there is no signals. Okay, students, so too easy. And the most important here, don't forget to write the infinity sign. Okay, let's go to next example. Okay, the second example here is need to draw -3u of n minus 5. So here we have 2 operations. Okay, shifting plus or minus, and scaling, which multiply by -3. So since we have -5, okay, shifting to the, if -5, we're shifting to the right side. So means our start point will be start from +5. 6, 7, 8 till infinity. Okay. Oh, sorry. Till infinity. So in general, the amplitude here for unit step should be equal 1. Equal 1 multiplied by -3 will become -3. Okay. It will be in negative part. -3. See, student, very simple. We did two operations, shifting and scaling. Shifting to right side and multiply it, the amplitude, by -3. Let's see one more example. Okay, this example, we need to draw -2u of n plus 3. So let's start with shifting first. +3. +3 means we do the shifting to the left side. Okay, so our start point will be start from -3. -3. Okay, -3, -2, -1, 0, 1 until infinity. Okay, now the amplitude, the original amplitude is equal 1. So 1 multiplied by -2 will become -2. Our amplitude become -2 until infinity. See, too simple. Let's take one more example. Okay, this example need to draw -3u of -n plus 2. Okay, if you notice here, we have -n inside the practice. So that's mean we have here 3 operations. First, shifting, then scaling, then flipping. Okay, so first of all, to solve this kind of question, we ignore this negative sign. We ignore the minus. Okay, we take it without minus. So -3u of n plus 2. Okay, so it will be like that, plus 2. Plus 2 means we start from, our start point will be start from -2. Okay, -2 -1, 0, 1 until infinity. Okay, that's the shifting. What about scaling? Multiply by -3. So our amplitude, we have amplitude with -3. Okay, done. That's for -3u of n plus 2. Now we include the negative sign. So -3u of -n plus 2. So now we do the flipping. Okay, as I mentioned before, we keep the first symbol same, which is from -2, and we reverse the other sign from this side, okay, to another side. If was in positive, we move it to negative. If from negative, we move it to positive. Okay, so it will become like that, like a mirror. -2, -1, sorry, -2, -3, -4, until -infinity. Okay, with amplitude -3. So simply reverse the signal to other side like a mirror, but don't forget to keep the first pulse same. Don't change it. We just reverse other pulses to other side. Okay, let's move to another kind of question, which is more common. So in the previous 4 examples in this lecture, and even in last lecture, if you noticed, in those examples, whether we did shifting or scaling or even flipping, the unit step continue to the negative part, to plus negative or to minus negative. Always it continued, and this causes some problem actually. Sometimes we need specified the unit step. We need specific set of pulses or samples that easy to control them later on when we use it in receiver. So in this example, we will learn how do we determine this signal and not let it to move to infinity part. Okay, look here. For u of n plus 2, n plus 2 minus 4u of n minus 3. Okay, we have two equations, between them a subtraction operation. And in this kind of question, the amplitude should be same. We should have same amplitude in both equations. If in here we have 4, here should be 4. If we have 5, here should be 5. Okay, this is the first condition for this kind of question. The second condition is if the first equation in negative or in positive here, the other should be in negative. So here if we have plus, here should be minus. Here if we have minus, the other equation should be in negative, should be minus. Okay. Okay, so to solve this kind of question, need to draw each equation separately. We start with 4 u of n plus 2. Okay. N plus 2 means we start from minus 2. We start from minus 2. Minus 1, 0, 1, 2, till infinity, with amplitude 4. Okay, this is first equation. The second, minus 4 u of n minus Okay, n minus 3. So n minus 3 means start, minus 3 means start from plus 3. 3, 4, 5 till infinity. Okay, the amplitude here minus 4. We have minus 4 amplitude. So minus 4. Okay, now we need to continue this. Okay, because we need to deduct this equation from the second one from the first one. So here 3, 4, 5, 4, 5 till infinity. Okay, so the most important here to draw both shapes or both figures evenly. Okay, it will be easy for us to deduct. So here, so u4 n plus of n plus 2 starting from minus 2 until infinity. Okay, that's the first one. The second, minus 4u of n minus 3 starting from 3 until infinity. If you notice here, we draw it with same lines. Okay, easy to deduct it. So from minus 3 here, from minus 3, so 4 minus 4, we subtract this figure from that one, so we deduct this part. We deduct this part. In result, we get this figure, minus 2 with 4 amplitude, minus 2 minus 1, 0, 1 until 2. Okay, so in result, we get a specific unit step. We call it deterministic unit step. And this is very important for next lectures. So start from minus 2 and end at 2. No infinity anymore. So in result, we get a deterministic unit step to take advantage of it when we processing the receiver later. Okay, it's too simple. It's like simple subtraction, like how we learn it early in school. Let's take last example for today. Okay, this is the last example. Minus 5 of, sorry, minus 5u, minus 5u of n minus 1 plus 5u of n plus 2. Okay, as you notice here, we have same amplitude here in negative and here in positive. So as I mentioned just now, to solve this kind of question, we need to draw each operation or each equation separately. We start with minus 5 u n of n minus 1. Okay, it will be like that. Minus 1 means our start point will start from plus 1. Okay, so 1, 2, 3, amplitude minus 5. Amplitude minus 5. This is the first equation. The second, plus 5 u of n plus 2. Okay, n plus 2 means plus n plus 2 means our start point starting from minus 2. So, and we have positive amplitude. So from minus 2 minus 1 0, as I mentioned just now, you need to draw it evenly, okay, to find the intersection process. This will be our intersection from 1 until infinity. Okay, you see here the amplitude is plus 5. This is also from minus 2 until infinity. Okay, so in the first figure, from 1 till infinity, the amplitude is minus 5. In the second figure, also from 1 till infinity, the amplitude plus 5. Here, plus 5. Okay, it's like intersection happened here in this part. In this part happened intersection. Okay, until infinity, actually, until infinity. So in the second figure, start from minus 2, but at 1 till infinity intersects with the first figure. They are same, but the different here is the amplitude. In the first one, we have minus 5. In the second, we have plus 5. So minus 5 plus 5 equal 0. That's why we deduct this part. So we just remove it. In result, we get deterministic unit step, means specific unit step from minus 2 until 0 with value plus 5 for the amplitude. So our result will be x of n minus 2 minus 1 and 0 with 5 amplitude. This is our solution. Okay. Okay, by the way, student, later the common question will ask you as engineer to create this kind of signal directly. So for example, here need to create a signal starting from minus 2 till 0 with 5 amplitude. Because when we have a receiver that needs processing later, to process it, we need a specific signal. We'll ask you to give a specific number of symbols. For example, from minus 2 till 10, not from minus 2 till infinity, okay? Specific symbols. And we cannot create this deterministic unit step if we don't have these two signals or these two shapes or these two figures, one deducted from other. Means the first figure with negative and the other with positive, or vice versa. So to get deterministic unit step, this deterministic is very important later in the receiver when we're gonna to process the signal that comes from source. Okay, student, I hope you understand this lecture. and everything is clear. Of course, this kind of question can be with more than 2 equations, 3 or 4 equations. Of course, with condition that have same amplitude, as I mentioned just now, same amplitude, and one equation got minus sign and the other got plus sign. Okay, hope this lecture is clear for you. Thank you and have a nice day.